Hello, we're on 1.07 Algebra 2 notes today. We're going to be talking about radicals and also complex numbers. So we'll talk about simplifying, combining, we've got radicals and imaginary numbers. The first thing we're going to start with is FOILing with radicals. So FOILing will be the same thing that we've done before, first, outer, inner, last, double distributive property. Except now it looks a little more challenging because we've got radicals thrown in there. Something else to take note of here is that these two parentheses are called conjugates of each other. And we'll talk in a minute, we'll write out what that means to be a conjugate. But essentially what we're saying is that they have the exact same numbers. They're both radical. 2 comes first, the 3 is the last term, but one's plus and one's minus. All right, so let's jump into our FOIL. So we're going to distribute our first term. So radical 2 times rad 2. So we've talked about before, when you multiply a radical by itself, you're left with whatever's underneath the radical, because rad 2 times rad 2 is rad 4, which is 2. Think rad 3 times rad 3 is rad 9, which is 3. Rad 7 times rad 7 is rad 49, which is 7. So when you multiply a radical by itself, you're left with whatever's underneath the radical. So rad 2 times rad 2 is just 2. And then we have negative 3 times rad 2 gives us negative 3 rad 2. So if one's under a radical and one's not, you cannot put them both under the radical or both out. You keep one in, one out. And then here we distribute the 3 to everything now. So we have 3 rad 2. And then our last term's positive 3 times negative 3 is negative 9. Now you'll notice here in the center terms, negative 3 rad 2 and positive 3 rad 2 cancel. And 2 minus 9 are like terms. We can combine those to get negative 7. So the good news is if you typed this whole thing into your calculator right now, you hit enter, you would get negative 7 for your answer. So these can be checked into your calculator. You just type, I'll show you real quick on this one. So you're going to type in rad 2 plus 3, and then rad 2 minus 3. And it gives you negative 7. So great way to check, but of course I need to see your work. So next, actually before we do number 2, let's just write out what a conjugate is, because what's really special about conjugates is that we're going to be using them a lot, because when you multiply something by the conjugate, you end up with a nice rational number here, like negative 7, and all of your radicals will drop out. So when we need to get rid of a radical, but it's part of a binomial, we would multiply it by its conjugate. So it's the exact same numbers, but the sign between them. And that's really important, that it's only the sign between them is different or is opposite. So if it's positive, then the conjugate would be minus. So for example, if I had negative x plus rad y, the conjugate of that would be negative x, so keep that sign in the front, and this is the one that's always hardest because people want to negate both of them, minus radical y. So the only thing that changed was this sign in the middle. Everything else stayed exactly the same. And those will come up quite a bit in the next couple of lessons, and throughout the year you'll be seeing conjugates. All right, let's try another one. This one is not conjugates because I'm going to have a binomial squared. So whenever you have a binomial square, you'll remember from algebra and geometry, you want to do the double bubble. I know some teachers call it. You're going to write it out twice because it's being squared. Once you write it out twice, now we're just going to FOIL again. So we've got rad 5 times rad 5 is 5. 6 times rad 5 will give us 6 rad 5, plus another 6 rad 5. And then our last terms would be 36. Combine your like terms. So I have 5 and 36 is going to give me 41. And when I add radicals, I add the numbers in front of them. So I get 12 radical 5. This can also be checked in your calculator. So you could type the original right here into your calculator, but it'll give you a long decimal. So when you do that, you want to type in the answer as well. So I'll show you this one also. So rad 5 plus 6, and then that's squared. And now, so we get a decimal. Then you would type in your answer. So 41 plus 12 radical 5. And we get the exact same decimal. So it's not as nice of a check, but it still does the same thing. You just have to type in your answer to make sure they give you that same decimal. All right, 2 rad 3 plus 4 times 6 rad 3 plus 8. So this one would be a good one to pause, see if you can get it. There's one thing that's a little trickier on this one, and that's these first terms when you multiply them. So remember, radicals multiply with radicals, non-radicals with other non-radicals. So go ahead and pause it and then check back with me. All right, so when we multiply these, we should have 12, and then rad 3 times rad 3 gives us just 3. And then the rest should be really similar to what we've done before. So 16 rad 3, 4 times 6 gives me 24, keep the rad 3, and then 8 times 4 gives me 32. Now we can simplify, so 12 times 3 is 36. I also have like terms right here, so 16 and 24 are going to give me 40 radical 3. The rad 3 stays the same. And then I have some more like terms, 36 and 32, to get 68, and then just bring down your 40 radical 3. Again, check it in your calculator, type the original in your calculator, and then type your answer and see if they give you the same decimal. So go ahead, pause, and do that now. Next one we're going to do, and this will be the last one with our foiling radicals, 3 rad 2 minus 5 times 4 rad 5 plus 7 rad 10. So the hardest one, for a couple different reasons, but starting right out, is that we've got more radicals in it. Take it step by step and do each one as you go. So 3 times 4 gives me 12. Rad 2 times rad 5 would give me rad 10. Then do the next one, distribute it to the 7 rad 10 now. So non-radicals multiplied together. 3 times 7 is 21. Rad 2 times rad 10 is 20. Now we'll go to the negative 5, distribute that. We get negative 5 times 4 is 20. Keep the rad 5, and then negative 5 times positive 7 is negative 35, rad 10. Here you want to check to see, is there anything we can do to put things in simplest radical form? And I see this one right here. We need that in simplest SRF as simplest radical form. So 10, 5, and 10, there's no perfect squares I can take from them. So I'm going to just jump down here to the next page. So I have 12 rad 10 plus 21. The largest perfect square I can take from 20 is a 4. 4 times 5. I always write the perfect square first, remember? And the square root of 4 is 2. So now I have 12 rad 10 plus 42 rad 5 minus 20 rad 5 minus 35 rad 10. So looking for your like terms here, I have 12 rad 10. You can always add or subtract anything that has the same radicand or number under the radical if there's no other variables involved. So we've got those, and then these both have a rad 5, the squiggly ones. So when I combine my like terms, I'll get negative 23 rad 10. Again, you just add the numbers in the front of the radical, keep the radical. And then plus 42 minus 20 would give me 22 rad 5. Again, you can check it, type in the original, and then type in the answer to make sure that those decimals match up. The next ones we're going to do is we're going to find the sum and the difference by combining like terms. And put your answer for these, because they're going to have an I in them. So put your answer in A plus BI form. All right, so that's first one is negative 2 plus 4i plus 6 minus 8i. Now I want to draw your attention because a lot of students, when they see these problems, they end up doing a lot of extra work and get it completely wrong because they don't look at the symbol in between here. So there's a plus sign. Students look at this real quick and they think that it's multiplication. So they think it's like this. I want to show you that this is very different than what I have here in black. So in the blue, that's if you would need to FOIL those. That's multiplication. That's not what we have here. In the middle between our parentheses, we have this plus sign. So all we're really doing is combining like terms. Since it's addition, you actually don't need those parentheses at all. And when you take them off, nothing changes. So now I just combine my like terms. Like terms for imaginary numbers means if they're like terms, they both have an I, or they don't have an I. So I have -2 plus 6 would give me 4, and 4 minus 8 gives me -4. So let's say I wrote it like this, -4i plus 4. This would be incorrect because that's not a plus bi form. What a plus bi form means is that the real part is the a comes first, and the part with the I comes second. So to put it in a plus bi form, I would just rearrange it using commutative property and get 4 minus 4i. Now it's an a plus bi form. Now in your calculator, there's an important button you guys are going to need to remember to push, and that's going to mode first, and then you're going to scroll down using your arrow. When here where it says real, you're going to go over to the right one and highlight where it says a plus bi, and that'll allow us to check a lot of these problems with i's in them right in our calculator. So very important to always keep it in a plus bi mode. And then actually you can literally just type in this problem, and the I in your calculator is second period plus in parentheses 6 minus 8i. So that's another really important thing to remember, that it's second period. And it gives you the answer. So again, I want to see your work combining your like terms, in the next one distributing, but I definitely would like you to check it on your calculator. There's no reason for anybody to get these wrong when you can just check them right in your calculator. All right, this one's a little bit harder because you have subtraction in the middle. So there's this -1 here that we need to distribute in. So just like when you guys combine polynomials in algebra, you need to make sure you change all the signs that come after the negative. So it would become -5 plus 18i, and that's one of the most common mistakes in algebra, but also in algebra 2. That students forget to do is they forget to distribute the negative to this term specifically. Now you're going to combine your like terms. So 4 minus 5 is -1. And then -3i plus 18 would give me positive 15i. And this one, I put in a plus bi form already. So the a comes first and the I part comes second. And that again can be checked on your calculator. So go ahead, pause, type in the original, make sure you're still in that correct mode, and then check if your calculator gives you -1 plus 15i. All right, moving right along, you're going to simplify for the next one. So this is 17 times the square root of -4 minus 12 times the square root of 32 plus 3 times the square root of -9 minus 8 times the square root of 50. And we just want to simplify, combine like terms, simplest radical form, and from there, always put your answer in a plus bi form as well, if possible. Okay, so first we have a square root of -4. Anytime we have a negative underneath the radical, it turns into an I. So the square root of 4 is 2, so this would just be 2i. Minus 12, set up my two radicals here. The largest perfect square I can take from 32 should be 16 times 2. Largest perfect square always comes first. The square root of -9, well, the square root of 9 is 3, and since there's a negative under the radical, I get an I. Minus 8, and the largest perfect square I can take from 50 is 25 times 2. Let's bring it down. So now I have 34i. The square root of 16 is 4, so that's going to give me 48 rad 2. 3 times 3i is 9i. So it's different when you're multiplying than when you're adding. If I was adding 3 plus 3i, I wouldn't be able to do anything with that or combine anything. But since I'm multiplying, I can multiply 3 times 3i to get 9i. And 8 times 5 is going to give me 40, so negative 40 rad 2. So again, we're looking for our like terms here. So I have negative 48 rad 2 minus 40 rad 2. So that's going to give me negative 88 rad 2. And then I have 34i plus 9i will give me 43i for my final answer. So a lot of work, but just make sure you take it step by step. And if you need to write out more steps even than I am, please feel free, if that helps you, to just sort everything out. Let's do another one. So simplify. 5 times the square root of negative 18 minus 3 times the square root of negative 12 plus 7 times the square root of negative 27 plus 7 times the square root of negative 8. So a lot of imaginary numbers in here. And we also have some that need to break down into perfect squares. So let's start the first one together, and then if you're feeling comfortable, pause the video and see if you can finish it on your own. So I'm going to take out a 5. As soon as I see a negative under the radical, right here, I'm going to pull out an I. And now 18 is not a perfect square, but there is a perfect square I can take from it. I can take out a 9, and 9 times 2 gives me 18. Okay. And if you're comfortable, pause it, see if you can continue on your own, at least for this next step. So here we have minus 3. I take out an I because there's a negative under the radical. Set up my two radicals. Largest perfect square I could take from 12 is 4. 4 times 3 is 12. Again, I have a negative under the radical. Pull out my I. Set up my two radicals. I can take out a 9 times 3 for 27. And then pull out an I because it's a negative. Largest perfect square I take from 8 is 4. Okay, so let's break it down to our next step. So the square root of 9 is 3. So I have 5i times 3 rad 2 minus 3i times 2 times rad 3 plus 7i times square root of 9 is 3. Bring down my rad 3. And then the square root of 4 is 2 rad 2. Let's continue simplifying. So now with multiplication and with i's, I can multiply it all together. So 5 times 3 is 15i rad 2. 3 times 2 gives me 6i rad 3. So the radicals still same rules. We can't do anything with those. 7 times 3 is 21i rad 3. And then 7 times 2 is 14i rad 2. Now in terms of like terms here, you have to make sure, that you have the same radicand, so the same number under the radical, and it has to have an I in the front, or they both have to not have an I in the front. So it's two things you're really looking for. So do we have any other terms that have an I in the front and a rad 2 under the radical? No, no, yes. Here I have an I with a rad 3, and I have another I with a rad 3. So let's combine our like terms here. So we get 29i rad 2. Again, the radicals do not change when you're adding and subtracting. Plus negative 6 plus 21 will give us 15i radical 3. And those cannot be combined because one has a rad 2 under the radical and one has a rad 3. The last thing we're going to talk about today is some more imaginary number stuff. It's simplifying powers of I. So the rule is you can never leave I to any power other than 1. Never leave I to any power other than the first power. And the reason is because we can simplify it if it's bigger than 1. So powers of I. How do we simplify it? Well, we know by definition that the square root of negative 1 is I. So now if I want to do I squared, square the square root of -1. And we just talked about earlier in the lesson, when you square a radical, you're left with whatever's underneath the radical. So rad -1 squared would give us just -1. What about I to the third power? Well, now we're taking I squared times I. So I squared is -1, so that would give us -I, and that is still to the first power. And then I to the fourth would be I to the third times I. And that would give you, or you could think about it as I squared times I squared, -1 times 1 would give you 1. That one's probably a little easier to think about. If you did I to the third times I, you'd have -I times I, so that would give you -I squared, and -I squared would be -1, which is 1. A little trick you can use is, I call this the I circle. So you do I, -1, 1, and it goes, the way I draw it, it goes counterclockwise. And you're always going to start at the top here. So the thing with these I's is that it's always going to happen. It's cyclical after 4. So then if you have I to the 5th, you're back to I. I to the 6th is -1. I to the 7th, I to the 8th is 1. So you're really looking at what's your remainder if you divide your exponent by 4. That's a lot for some students to process. So sometimes this little circle helps, and you just start by counting. Let me show you an example as I do it, because I think it'll make a little bit more sense that way. And also, these can all be checked in your calculator. That's a little check mark for checked in your calc, but it must be in A plus BI mode, that mode we just switched it to. All right, so we've got 2I to the 7th minus 3I squared plus 5I to the 8th power. So one way of doing it is to say, okay, well, 7 divided by 4, 4 goes into 7 one time, and that means I have a remainder of 3. And I to the third is -1. So whatever your remainder is, you would take that I. Or a lot of students like to use the I circle. So if it's I to the 7th, you'd start here at this top one, I, and you'd count 1, 2, 3, 4, 5, 6, 7. And we landed on the -I when we were at 7. So I to the 7th is the same thing as -I. Then I do -3 times I squared. So again, I'd start at the top with number 1, and I would count. So I'd count 1, 2. Well, at 2, I'm at -1 now. So I squared is -1. Now that's the one we're going to use the most, is I squared. So hopefully you have that memorized. If not, from your circle, and you can also just type in I to the second power, I squared, will give you -1. Plus 5, I to the 8th. So 1, 2, 3, 4, 5, 6, 7, 8. So that is a 1. And again, there's no remainder if you divide 8 by 4. So I to the 0 power is just 1. Now let's simplify. So we have -2i. -3 times -1 is +3 plus 5. So that gives me -2i plus 8. But that's not an A plus BI form, so we need to switch it to be 8 minus 2i, so that it's an A plus BI form. Again, really nice in your calculator. If you go to your calculator, you can type in 2i raised to the 7th minus 3i squared plus 5i raised to the 8th. And it gives you the answer 8 minus 2i. But I want to see your substitutions as to how you got it. But you are more than welcome and encouraged to check it in your calculator so you know you got it right. The more you can check in the calculator, the better. The next one is 7i to the 14th plus 5i to the 11th power. So pause the video here, try to count using your I circle for each one. So you're going to start at here and count to 14, and then show your substitution. Do the same thing for I to the 11th power, start here and then count to 11. show your substitution, and then check it in your calculator. And I'm not going to go through that one. Use number 9 if you need more help. And then I'm not going to give you the answer because I want you to check it in your calculator to get the correct answer. And the last ones we're going to do is just to practice on our calculator, because while the calculator is obviously very helpful, it also can make it more challenging sometimes because it gives us some really funky answers. And if you have the TI color, the one where you have to charge, that one does better. It gives you more, but it still doesn't give you all of them in a nice form. So the first one, let's type in I to the 27th. So just go to your calculator and type in I raised to the 27th power and hit enter. Oh, and this one did work for me. So you would just get negative I. Some of you, if you have an older operating system, it maybe didn't give you a negative I because my other calculator hadn't. But I think, oh, this one is the newest one. So if you have a calculator like we do in school, the calculator would have looked like this. So 3e negative 13 minus I. So if that's the case, you want to find the e and then find whatever's next to it, in front of it and behind it. And all of that becomes a 0. So what's that really saying? Negative 3 times 10 to the negative 13. So 0.00000. It's just the way the calculator computes these, it comes up with the scientific notation instead of just a 0. So you're left with just minus I for your answer. So you're always looking at where the scientific notation is, what is that being added or subtracted to? And whatever is being added or subtracted to, that's what you want to keep. And you're going to take off the scientific notation. That becomes a 0. Okay, let's try another one, I to the 14th. So again, if you have the newer calculator, it'll probably work. If you have an older one, it would give you negative 1 minus 4e to the negative 13i. So find your scientific notation. So find the e, whatever comes before it. So the 4 and comes after it, negative 13i. That all goes away. And then whatever it's being added or subtracted to, that's your answer. So negative 1. For number 13, let's do 3i to the 67th plus I to the 19th. Try this one in your calculator. Pause the video. So your calculator should have given you something like this, or it maybe gave you the answer. Either way, you need to know how to read these because they won't all be nice and give you the exact answer. So find your scientific notation, the e, the number before the e, the number after it, and you're left with negative 4i. And 14, let's do I to the 92nd power. Pause the video and see what you get. Okay, so that one should give you 1 minus 8e to the negative 13i. Find your scientific notation, and you're left with just 1. All right, if you have any questions at all, please make sure you let me know. And I hope you enjoy the rest of your day. Pi out.